HTML describes the content and appearance of a web pages. It doesn't describe the structure and meaning of the data. XML, however, can define meaning and the structure of the data. An XML document should begin with an XML declaration. We have also something called XHTML, or Extensible Hypertext Markup Language. Markup language is based on XML. It's also a stricter version of HTML. Web browsers continue to support the HTML and have been slow to adopt the XHTML specification. However, as more companies use XML, more XHTML-based web pages will be created and used on the internet. Extensible Style Sheet, or XSL, is a standard language for creating a style sheet for XML document. Style sheet is a document that can specify how to process the data that is contained in another document and present the data in a web browser, or in a printed report, or on a mobile device, in a sound device, or other presentation media. This is an example of XML schema for the rate element from the rep table. This is also showing you the interaction among XML and related languages that's out there. The last part that we are going to talk about is about data warehouse. When users interact with the relational database management system, they use transactions, such as adding a new record or changing customer sales rep. These type of systems are actually being called online transaction processing system, or OLTP systems. For each transaction, OLTP typically deals with a few rows from the table in a database in a highly structured, repetitive, and predetermined way. If we need to know the status of a specific customer, parts, and order, or if we need to update data for specific customers, parts, and order, the Relational Database Management System and OLTP are basically a great tool to use. So what is a data warehouse? Data warehouse is a subject-oriented, integrated, time-variant, non-volatile collection of data in support of management's decision-making process. It's being used for analysis of existing data. It also resolves performance issues suffered by operational relational database management system and OLTP. For the operational application, large companies use a variety of database management system and file processing systems that haven't been developed over a period of many years. This is a data architecture example. Data warehouse contains read-only snapshot of highly consolidated and summarized data from multiple internal and as well as external sources that are refreshed periodically, usually on a daily or weekly basis. Organizations use data warehouses in support of their decision-making process, which typically consist of unstructured and non-repetitive requests for exactly the type of information contained in a data warehouse. Now let's look at data warehouse structure and access. A typical data warehouse structure is actually star schema, which is combination of fact table and dimension table. So the central sales table is called a fact table. A fact table can consist of rows that contain consolidated and summarized data. The fact table contains a multi-part primary key, each part of which is a foreign key to the surroundings dimension table. Each dimension table contains a single part primary key that serves as an index for the fact table and contains other fields associated with the primary key value. The overall structure is shown actually here. Access to a data warehouse is accomplished through the online analytical processing software, or we call it OLAP. OLAP software. User can visualize the data warehouse as a multi-dimensional database in a shape of data cube. Data mining consists of uncovering new knowledge, patterns, trends, and rules from the data stored in a data warehouse. You use the data mining software to answer questions such as which product best attracts new customers, what factors best predict which customer default in making payments, what are the optimal seasonal inventory levels based on predicted economic factors, what is the optimal number of customers to assign to each sales rep. So this is an example of a data cube representation of part, customers, and time dimensions. Rules for OLAP systems could be as follows. Multi-dimensional conceptual view. Users must be able to view the data in a multi-dimensional way, matching the way data appears naturally in an organization. For instance, user can view data about the relationship between the data using the dimension of parts, customer, location, sales rep, and time. Transparency. Users shouldn't have to know how they are using a multidimensional database, nor need to know how to use a special tool to access the data. Accessibility. Users should perceive data as a single user view, even though the data may be physically located in several heterogeneous locations in different forms. Consistent reporting performance. Retrieval performance shouldn't be degraded as the number of dimensions and the size of data warehouse grow. Client-server architecture. The server component of OLAP software must be intelligent enough that a variety of clients can be connected with minimal effort. Generic dimensionality. Every dimension table must be equivalent in both its structure and operational capability. Metrics handling. Missing data should be handled correctly and efficiently, and not affect the accuracy or speed of data retrieval. Multi-user support. OLAP software must provide secure concurrent retrieval of data. Unrestricted cross-dimensional operations. Users must be able to perform the same operation across any number of dimensions. Intuitive data manipulations. Users should be able to act directly on individual data values without needing to use menus or other interfaces. Flexible reporting. Users should be able to retrieve data results and view them in any way they want to analyze. Unlimited dimension and aggregation level. OLAP software should allow at least 15 data dimensions and an unlimited number of aggregation levels. The last thing that we are going to talk about is about object-oriented database management systems. Normally, organizations use relational databases to store and access data consisting of text numbers. Additionally, some organizations store and access graphics, drawing, photographs, video, sound, voicemail, spreadsheets, and other complex objects in their databases. Relational databases store these complex objects using a special type, generally called binary large objects, or BLOBs. Object-oriented database management system used with application whose focus is on complex objects. What is an object? Object is a set of related attributes along with associated actions or functions. Object-oriented database management system is a system in which data and associated actions or functions are encapsulated into the objects. So we can represent each entity as an object rather than a relation. We list the attributes vertically below object names, follow each attribute by the name of the domain. Objects can contain other objects. An object can contain a portion of another object. So what is a method? Method is action defined for a class, defined during the data definition process. It can be executed when users send a message to the object. This picture shows two methods that are associated with the order objects. The first method, add order, adds an order to the database. In this example, user can enter data, then the program places the data temporarily in a computer memory in a work area named wOrders. The wOrders record consists of a user entered value for the order number stored in wOrder num, a user entered value for the order date stored in wOrder date, and so on. In this figure, the second method deletes the order, which is called delete order. The only data a user inputs to this method in the order number to be deleted, which is placed also temporarily in wOrder num. Next thing that we are going to talk about is inheritance. A key feature of object-oriented system is called inheritance. For any class, you can define a subclass. Every occurrence of the subclass is also considered an occurrence of the class. The subclass inherits the structure of the class as well as its method. Also, you can define additional attributes and methods for the subclass. Next thing that we will discuss is called Unified Modeling Language, or UML. UML is an approach that we can use to model the various aspects of software development or our object-oriented systems. UML includes a way to represent database design. So in UML, we have something that's called class diagram. In class diagrams, rectangles represent classes. Line joining classes represent relationship, and they're being called association. Visibility symbols indicates whether other classes can view or update value in the attribute. So this is an example of a class diagram. At each end of each association is an expression that represents the multiplicity or cardinality of the relationship. As we have discussed this before, multiplicity indicates the number of objects that can be related to an individual object at the other end of the relationship. UML provides various alternatives for representing multiplicity. In our diagrams, we can also specify constraints, which are restrictions on the data that can be stored in the database. In UML, the entity subtypes are being called subclasses. Also, when one class is a subclass of a second class, we can call the second class a superclass of the first class. The relationship between a superclass and subclass is also being called generalization. This example is actually representing the relationship between the students and student dorm. So in this example, you have a class diagram with a generalization as well as a constraint. There are also some rules for object-oriented database management systems. First, complex object. An object-oriented database management system must support the creation of complex objects from simple objects such as integers and characters. Object entity, which must provide a way to identify objects. That is, the object-oriented database management system must provide a way to distinguish between one object to another object. Encapsulation. An object-oriented database management system must encapsulate data and associated methods. Information hiding. An object-oriented database management system must hide from the users of the database the details concerning the way data is stored and actual implementation of methods. Types or classes. Types are very similar to classes and also correspond to an abstract type in the programming languages. The difference between these two are subtle and will not be explored here. Inheritance. An object-oriented database management system must also support inheritance, late binding, as well as computational completeness. Also, extensibility. An object-oriented comes with a set of predefined data types, such as numeric and character. An object-oriented database management system should be extensible, means that it's possible to define new data types. Also, another rule is to be persistence, as well as performance. An object-oriented database management system should have sufficient performance capability to manage very large databases. Also, another rule is concurrent update support, which the database management system must support concurrent updates. Also, recovery support as well as query facility. An object-oriented database management system must provide also the query facility.